Before we start, I'd just like to say thank you to my dad for supporting me with this project because it's been... So, let's get started. So, I started programming about, I think it was 5 years ago, so when the Raspberry Pi kind of started out. And I fell into it a really weird way. So my mum knew a person who started the Raspberry Jam movement. That actually started in Preston, where I live. So I kind of got into it just by chance, really. And I'll explain what my current project is. So I've developed some software called EduBlocks. And to put it simply, it is a drag-and-drop version of Python 3. So when I started learning Python just over 2 years ago, I found it quite hard to get used to the syntax. With being a student, I see firsthand that people in class struggle learning text-based programming languages. And I kind of developed a way to make this easier. So I took Scratch as an inspiration, and I created drag-and-drop Python. So EduBlocks is kind of my solution to this. It's an easy way to learn the Python 3 syntax, so I'll explain how it does that with a demo in a minute. So it has the Scratch-like interface, but instead of having just random text on the Scratch blocks, it actually has Python code. It's an educational tool to help younger children make the transition from Scratch to Python. So the problem that we've got in the UK at the minute is that Scratch and Python is quite a low age in the education system. So children are finding it hard to learn Python, so they're going straight from Scratch and having no knowledge of how to type programs. So this is kind of to make that transition easier. It's also a platform for educators and teachers. So resources are provided for free. You can just pick up a resource and your lesson is underway. So why did I create EduBlocks? So we'll start with a few statistics. So in the UK, a new computing curriculum was introduced in 2014. So the government saw that computing is this up-and-coming thing, that jobs are needed in software engineering. So they introduced a new curriculum. But the problem with this new curriculum was 74% of teachers had inadequate training. So the teachers couldn't really teach it because there was no resources, there was no training given to the teachers. So they were kind of at a loss of what to do. But this has improved over the 4 years that the new curriculum has been introduced. So we've seen PyAcademy, which I'm sure many of you have attended PyAcademy in the US. So there's all sorts of different training programs in the UK and the US now to help this make it easier. So what does EduBlocks do? So this is kind of a typical Scratch program on the left. So you set a variable and then print the variable. And this is Python on the right. So you can see that it's Scratch is kind of drag and drop. It's got the visual blocks. But then when you go into Python, it's straight away you have to type it out. And for high school kids, so about age 11, this can be quite daunting if you've never done it before. So there's no in-between solution to bridge the gap. So this is EduBlocks. So you kind of got the same visual idea where you drag and drop the blocks, but you're actually learning Python at the same time because you got the Python code whilst you dragging and dropping the blocks. So it's kind of that in-between solution. So how does it help people? So as I have already mentioned, you have the Python code on the blocks, so you can see what you're doing in Python, but you're doing it in an easy way. It gives you the option to download the Python file. So once you drag and drop your blocks and build up your Python program, you can then export it and edit it as a normal Python program. You've got a Python view, so you just click a button and you automatically get a text editor in which you can edit the code and look what it would be if you were typing it. So what platforms does EduBlocks work with? So I'm sure you've all heard of the Raspberry Pi. You may use it in school. So the Raspberry Pi is a $35 computer. So it's quite small, but it can do all the things that a normal computer would do. You've also got this device called the microbit. So this was given to 1 million children in the UK back in 2015. So that is a small, I think it's $10 computer, and it has lots of features which I'll show you in a minute. So let's start with the Raspberry Pi version of EduBlocks. So I've already explained what a Raspberry Pi is. So it was used to kind of help teachers with the new computing curriculum. So it was an easy way to introduce physical computing and coding without having the barrier to entry of cost. So this is the Raspberry Pi edition. This is where it all started. So the Raspberry Pi edition includes all your basic Python commands. So you've got while true, print statements. But you've also got Minecraft. So the Raspberry Pi has a really cool Minecraft edition, which you can actually program with Python. So that's in EduBlocks. You've got GPIO 0, which was made by Ben Nuttall from Raspberry Pi. And that is an easy way to control LEDs with physical computing. Sonic Pi, which is making music with code. That was created by Sam Aaron, and that's being used in over, I think it's 1 million people that are using that now. You've got all sorts of different add-ons like the SenseHats, which are in space. So that's just a quick overview of all the different things that you can do. So if we have a quick demo of this, so you can see that it's very Scratch-like. You've got your toolbar at the left, and you just drag and drop the blocks of Python into the workspace. So you still got the same Python commands, but you're used to how Scratch works, so it's quite familiar. And then you just type in the boxes. And then if you click the run button, it'll run it as if it's a normal Python script. Oh, skip one. So the, oh, doesn't want to work, does it? Try playing it. There we go. So this is a add-on board called the Blinkt. So the really cool thing about the Raspberry Pi is it has these GPIO pins, and companies like Pimoroni and Adafruit make add-on boards that can go onto the GPIO pins. And that provides a fun way to get into coding. So as you can see, this is the Python view. So you just click the button and you get the text editor, and then you run it and the lights will come on in the corner. So the next demo is Minecraft. So this is quite a popular one because all kids love Minecraft. So you drag in and drop in the blocks before, but you can see that you're building up an actual Python program. So this will just print something in the corner. Now, because of the resolution of the Pi, you can't really see it, but there should be like a bar that comes up. It does say it, I'm not lying. So let's go on to the microbit. So the microbit is, as I said, it was given to every 11 and 12-year-old in the, it's meant to say 2015, but. So a microbit has all sorts of different features. So it can be programmed in MakeCode, Python, and all those programming languages. And it has a 5x5 LED display. So the first thing that you do with a microbit is get it to scroll your name, because that's a fun thing to do. So the microbit edition was introduced back in, when was it, November, I think. And it came up as an idea at PyCon UK, at the Education Summit. So I spent 3 months developing this, and it finally became a thing. So it's still got the same interface, but instead this runs on any computer instead of just a Raspberry Pi. So as long as you have a microbit, you can just go to microbit.edublocks.org and you should be able to have a go with it. So you can still switch to Python view, but the way the microbit works is you actually download a file and upload it to the microbit as if it was a flash drive. So turn the lights off so you can see it. So you can kind of make out that it's scrolling Hello World in the corner there. So where is EduBlocks currently? So I started EduBlocks, I think it was about 2 years ago. So I started out with Scratch and did a few Scratch projects, and then someone said, oh, why don't you learn Python? And I was like, I don't want to learn Python. And I'm kind of glad I did now, because it's got me further than I ever thought it would do. And Python in the UK is only being taught to Year 9, which is 13 and 14-year-olds. So it's still quite an old age to be learning it. So EduBlocks is kind of making it easier for younger kids to learn it, because Python should be something that should be learnt much earlier, because the earlier you start, the better you become with it. So it's now got 9,000 active users, and that goes across 72 countries. So it's expanding each month, and there's always new things coming. So education, this is a fun thing. It's being used in schools around the world, so whether that be teacher CPD training in the classroom or at events like PyCon and stuff. So there's been lots of feedback from teachers saying that it's helped their children kind of learn Python, and it's really good to see that it's making an impact on so many schools, because that was kind of the goal from the start. It had a slow start, but then as more and more people found out about it, it's kind of expanded. And we have a quick video from a former teacher and a STEM ambassador explaining what EduBlocks is and how she uses it. Oh, doesn't want the... Right, audio cable. All right. There we go. Hopefully.
Hello. Josh asked me to talk about EduBlocks to you and explain my experience of using it with code clubs and with outreach. And what I do as part of working with Pomeroni is I go into schools and I try and get children into learning STEM, learning tech, and learning how to code. And one of the main problems I find as a former special educational needs teacher is that children don't necessarily grasp the syntax of coding. And although Scratch is useful, and some of them have picked it up, a lot of the concepts are very abstract, whereas with EduBlocks, they're very, very clear as to what they mean. I find that EduBlocks is great for Sonic Pi, it's great for Minecraft, which obviously draws children in because all children love Minecraft. It takes out the pain of GPIO 0, which is a great way of controlling things using your Raspberry Pi, but with EduBlocks, it's completely painless. Also, I work for Pomeroni, so I'm kind of biased because there are so many libraries for Pomeroni add-ons also within EduBlocks, which is great. You're not just left to fend for yourself either. There's a whole learning portal. So Josh has actually created tutorials which guide you through all these new concepts and all these new things. I described it as a work of chuffing genius, and I'm not joking. Josh knows, he's tested it in the field. I've seen him deliver excellent coding workshops to his peers and to people way more experienced than him. And he knows what it's like to be frustrated to have to wait for all your typing to come true, as it were. And by making EduBlocks, he's made it fundamentally clear, fundamentally easy, and anybody can pick it up. So I would recommend it to anybody.
Right, so along with EduBlocks as a program, I've also developed some resources and lesson plans. So the lesson plans are made in conjunction with some trainee teachers in the UK. So there are lots of free resources. So EduBlocks is free itself. There's nothing that's paid for. So everything's free to use the program. So that kind of lowers the barrier to entry if you want to use it. So you can just go to the learning portal, get a resource sheet, and it'll guide you through all the steps to get started. So lesson plans, there are more coming of the lesson plans. I just need to finish work on some of them. But there are a few up there already. So it has all the things that you need to do a lesson. So you've got the actual lesson plan itself, and you have the PowerPoint to go alongside it, as well as the worksheets. So it comes with a full package. So you've got your lesson objectives and explanations in there. So that's all there. So the next step is to develop some hardware for EduBlocks. So I think in the unconference bit, I'm going to ask some teachers what they think of new ideas for boards to add. So this is the first one. So it's a simple Pelican crossing. So you just put that on your Raspberry Pi, and you have access to a buzzer, which if you have 30 of these in a classroom, it can get quite loud. And then if you've got a teacher that you don't like next door, you can really annoy them. So you've got your traffic lights, red and green man, and a button to go with that. So it comes as a kit or pre-soldered. So as well as learning coding, you can also do a bit of electronics as well. So that's just a starter board to get started with that. But some ideas would be greatly appreciated for where to go with the next one. The next step for EduBlocks is to get CircuitPython working with it. So this is the Gemma M0, and it's a small $10 microcontroller, and it can run Python. So you've got, this is an example with the onboard .star, but I've also got pin control working, so you can hook up motors with PWM and all that sort of stuff. So if you'd like to see a demo of that, I'd be happy to show you. Future plans, so we have the lesson plans, which I mentioned, so that's kind of the next step. EduBlocks for CircuitPython. The thing that's not on there is I also want to, in the future, merge the Pi version, the microbit version, and the CircuitPython version all together, and include some basic Python stuff in there. So kind of getting the basics of Python. So something like that would be quite good. And also the MindSpark range of educational boards for the Raspberry Pi and the microbit and stuff like that. So the good thing about EduBlocks is it's all open source. So if any developers out there want to help with code, or even teachers who want to submit an issue or a feature request, I'm always happy to add stuff in. So it's all open source on GitHub, so if you just go to that link, you can see the code there. With EduBlocks being a free project, it's always going to be free, but unfortunately these things aren't free to run when you have to buy boards to test it out and stuff. So there is a Patreon page if you just want to put $1 in or something to support EduBlocks. It's greatly appreciated because it allows the project to move on further and also helps me out with testing so that you get a better user experience. If you'd like to find out more, there's a website at the top, edublocks.org, or you can find me on Twitter or send me an email, I'll be happy to reply with any questions. Thank you. So does anyone have any questions that you'd like me to answer now? Yes.
Have you tried EduBlocks on mobile?
A really cool feature about EduBlocks is if you run the Pi version and go to the IP address on your iPad or phone, you can actually program your Raspberry Pi from that. A mobile version would be something that I want to look at with like basic Python commands. So that could be something that could come in the future. I have actually started work on a basic Python thing that would run on anything with a web browser. So that is something that would come in the future. So EduBlocks is mainly written in JavaScript, and it uses the Google Blockly API, which basically you program the blocks and then that'll generate some code to send to a Python server, which will then run it as if you typed it. So yeah, so it's mainly JavaScript, but there's Python and TypeScript and stuff like that in there. So it's really a range of different languages to make it. Most of it is a massive hack to get it to work, but it does the job. So maybe one day I'll tidy up the code, but for now it works. So yes.
Are there any students who use this without using Scratch first?
So in workshops, I've ran an EduBlocks workshop with some 8-year-olds who had never touched programming before, and they didn't really make any errors. So yeah, you don't really have to start with Scratch. You can go straight onto this, because it is basically the same interface. But you can start with Scratch, and then EduBlocks, and then Python. But yeah, you don't need to if you don't want to. Yeah. Okay, thank you.